Hi, programming engineers. Welcome back once more to this drives course. So today I'm going to be showing you guys about digital inputs, because we saw our connection type for our digital inputs. Remember that we have two of them, two types. Our two-wire connection and our three-wire connection. And as we saw, for each entry, we have that signal which is on hold for a drive. Okay? However, these signals, these inputs or these activities, we are able to assign through our configuration for parameters. Now, what do I mean by this? If I wish that my signal, let's say for my two-wire connection, it is by default that it indicates us that S1 signal or input number 1 should say that whenever this is activated through our button, for our regularly open button, it's going to move our motor forward. And for input number 2 is going to move, but in reverse. So our advantage here is that I'm going to assign in my input number 1. And I'm going to be able to assign for entry number 2 so that it moves forward. Now I can assign each input to whatever I wish. Obviously that it's within my drive possibilities. So we're going to run a comparison on how before my frequency drives existed, we did our start-stop. Okay? So for our old machines, we had our contactors. Well, we still have these, and we still use these. But I'm saying, or I'm talking about our automatic part. Our contactors or our contacts that we used earlier were much more robust. And there wasn't a logical controller or a mini PLC, an internal mini PLC in a drive, or in a frequency variator. There wasn't one. So therefore, when activating our motor as far as start-stop or reverse was something a little bit more different. So maybe some of you had already run or already seen our electrical connections for our contactors or for our contacts. So someone probably did this already. So then it's going to be much easier to understand for you guys. But for all of you guys, all of you engineers who are, this is the first time that it's going to be for our drives, taking this drives course, you need to pay close attention to this. Okay? It was all about playing with our electric circuits so that we can start or stop our motor. Now, what do we see here? This could be 120 volts. We have our thermomagnetic switch, which, remember that it helps protect my electrical equipment. Or we can protect ourselves by avoiding electric discharge, or whenever the current shoots up and there's a short circuit, there's going to be a peak. There's going to be a surge, and in that surge is going to be larger than our established connection in our electromagnetic pulse, our EMP. And it's going to open the way for our energy for everything, for our thermomagnetic. Okay, so we have our switch, and on the bottom part, we have our contact. Okay? So our contact is going to help us protect our motor, our electric motor. And together with our thermal connection, it's going to help us get a motor control. Now, how does this work? Remember that our contactor and our relay work thanks to our coil activation. Now, these coils are generally fed with a positive and a negative. Now, there are certain coils that are for AC and DC. Now, if we choose direct voltage or DC, then we're going to go to our control part, which are 24 volts. But we can also feed through a neutral or a phase, which is AC. Okay? Now, whenever we feed, okay, whenever we feed and we close our circuit, we are going to assign our coil depending on what it's asking us for. But if we comply with our goal of closing that circuit, then in that case our contact is going to be part of a switch. If the coil is not energized, then the contact is going to be open. So all this does is to assign the necessary voltage so that our switch can start. So if there's no voltage, then this means that our contact is regularly open. But what would happen if we open our feed, and well, if we feed our circuit between A1 and A2? So if we feed with a positive and negative, it is going to close our circuit. And so therefore, it's going to allow the current to go through, and we're going to be able to start our motor. Now, guys, I'd like to give you guys a tip for our contactor part. Remember, guys, that there are different coils, and we need to be very careful with our control part. Generally, when we see 24V, we get overconfident and we say, oh, well, that's control. And logically, we're going to use our voltage, our direct voltage, or our DC, our direct current. So that's the logic for all the automation engineers. Okay? The problem here is, and this is my tip, or this is another one of the tips, be very careful when you already have stored your 24-volt coils. Because sometimes salespeople, what they want to do is they want to give us our contacts or our coils that are 24 volts, yes, but they want to give them in AC, 24 AC volts. So you need to be very careful with this, because I've had very bad experiences that by being overly confident, and when we want to connect our contact, it needs DC. And that's because of the specification, our specs that we were sold, it was sold to us. So be very careful with this, guys. Okay. Now, there are some other times that they actually don't even give you a DC or AC. They only give you 24V, okay, for volts. And also what they do is they add an A with a V for, they add a space between the A and the V, which is actually alternate voltage or alternate current. So it's not really going to work. And if it works, it's going to burn out. So it's not really going to have the potency to activate itself. But that is my tip. So if you see that a contact is acting weird, and it's checking that everything is in order, then what you need to do is you need to analyze the coil, and you need to check that this is direct and not alternate. Okay, so you need to check that it's at least DV, not AV, if they give it to you like this. Okay, so this is how it works, or this is how they used to work. Everything related to the activation for our digital inputs, which is a button here. It's a button switch, a button box, and these are the inputs. So this is basically this, but this, thanks to the pulse that we assigned, the inverter or the drive or the variator already knows what it's supposed to do. So it's a little bit more automated, so to speak. Only with our configurations, our drive is going to know, or our driver knows what it has to do. So our button that we have here you have it at S2. Now let's say that this is input number 2. So this button is regularly open. And it does not allow for it blocks the signal unless we push this. And if we push this button, then it is going to activate, and we would need to run an electrical connection so that it is stuck, that it's enclaved. And it's going to close the circuit so that it allows for electrical current in our motor. So the start, we basically can't control it at 100% because we can't know exactly what is its acceleration and deceleration is. So this has already been predefined and defined on the physical part, which is something that with our drive, we are able to prevent and assign our acceleration and deceleration. So this is connected in series. Everything that has to do with our stop button. So our stop button generally goes before our startup button. And this is before, this is ahead of it because it is in its block or the contact. And in case this allows for it to go through, when we press our stop button, then it's going to declave our circuit. And it's going to open everything up so that we don't have anything for our motor. And so therefore, we have our startup phases, unless we press our start button. Now, looking into this in an electrical diagram, we have our switch for our phases, for line 1, line 2, line 3, and we have our contactor, and here we have our discharge part. Now here on this side we have our motor. Okay, so here we have our electrical or electric connections for our stop buttons and start button. Now, this may be very simple for all of you because you probably have already seen this in your electric circuits. But anyways, I'm going to explain this to you. Here, we are interrupting our phases. Okay? So we're going to add our stop button, which is regularly closed. And as I said, it needs to be before the circuit in my start button. And this start button needs to be as regularly open. And we also need to enclave in our contact for it to be activated in our coil for our contactor. And so this way we would be able to have our relay contact, our thermal relay contact. And so therefore we would be able to start our motor. So all we need is to play around with our circuit. This is the old way of doing this. Every time that it's done, there's still companies that do so. But how feasible is it to do this? Well, not really, not anymore, because we still have our variators, which protect our equipment. And we're also saving money in our pocket, which is a better control part for our electric. Okay, so this is how they previously worked, and now we are going to move on to our manual. So we're going to analyze how the digital inputs work for our drive. Now, how are we going to know those parameters so that we can configure our digital inputs? My recommendation is, well, remember that we're in Spanish, so we're going to look for this as inputs or digital input as such. So now we're going to be, it's going to tell us now that what it's set by default. So whenever we get our drive, we have a default configuration. And these are the default configurations that we need. So we're going to continue looking for this, okay? And this is how each one is made up of internally in our drive regarding its input or their digital inputs, okay? So we're going to continue looking for this. And it's right here. But let's put it forward. So it's at 243, I think it said here. So we're going to continue looking for this, 245. Here it is. Multifunction. I think it was two. I know I saw that. Here it is. Okay, so we're going to locate. And we didn't find it because it's a digital input. So it's generally as multifunctional digital inputs. Why multifunctional? Because we can assign for each digital input the function that we can choose. Okay? Now, what do I mean by this? We're going to look for it in our simulator, okay? And this digital input is assigned, for example, as rogue command. So this is how it's assigned. I can change it even to that function. Related to what? Related to its activities, to its functions. So here it's telling us, all right, so in our parameter, if you select the parameter H101 or H101, you're going to assign that task to S1 input. If I select H1 S02. Then I'm going to assign for S2 input a chosen function or a chosen task. So H103 means that I'm going to assign a function to input number 3. So H105, digital input S5, H106, digital input S6, and finally, digital input S7. Okay? So with this, we already decided which digital input are we going to choose. Okay? So if I choose H103, I'm going to modify S3 input according to my manual. Okay, so what function am I going to assign this? Well, it all depends on what I have for my list. Okay, and that's going to be in our manual again. Now, further down, we have H1. Okay, so for H1, whatever we choose as an input, we are going to select which function is that digital input going to have. So if I add, or if I say that my input, whatever we ran previously, which was, I think, digital input S5. Let's see this. So that's S5. No, it wasn't stored here. It said that it needed to be assigned as a 3-cable sequence. So with this, we ran our implementation for 3 cables. So this is very important, guys. Now it says if it's selected when it's closed, it is going to be in reverse. So we're going to start our drive. Actually, our drive is going to be in reverse. Okay? So this is how we selected it. And this is how we ran it in our previous video. But if for my input, if I say, well, I don't want it 3 wires. So what am I going to add? I want to add an overheat alarm. So I'm going to connect it here, a device, so that I can show the alarm for the H2. Or that I want, whenever I select my button that I have it connected, for my digital input number 5, then now I want it to jog slowly forward. So it's going to say, well, it's going to move forward whatever I have it assigned for my B117 parameter. And if I want my digital input number 6 is now a slow start, then I'm going to assign it as such. I'm going to select my H1 drive, 06, and then I'm going to assign number 13. Okay? What else, guys? If I want that my digital input number 3, okay, my digital input number 3, if I wanted to indicate that it has an external failure in my drive, which means that whatever my line has for my machine, whenever it has a unidentified object in our conveyor belt, then if there's an object that is present, that means that something is wrong and that I shouldn't move forward with my line. So therefore, I need to assign a sensor that is in my digital input S3. Now this is connected through my S3 and my SC, my common. So that's where I can connect my sensor for a forbidden or an unallowed material. If it's detecting that sensor, then in this case, I wanted to do the following: an external failure or external flaw. For that external failure, we are going to select it And we're going to go depending on what I want. If it's a button or a regularly open sensor, and what I want it to do. If it's stopped, or if it's an inertia brake, or that it may be that it gets an alarm. Okay, now what do you want it to do? I want it to always detect, or I want that whenever it works, I want it to stop. So here it has the various different options. So you need to detect what you choose depending on the application. Okay, so here we have our forward command. So this is by default, I think. Okay. No, it's not set by default, but I think it's the 2-wire one. So therefore, it should be this one, this part. Okay. So depending on what we need is what it's going to run for our drive. Now, how is this connected? Digital input, multifunction, digital input. All right, so how is this connected then? It's very simply put. Here we have our drawn for our terminal, and generally it's going to be, depending on the manual, it's going to indicate if they need a regularly open button or a regularly closed button. However, for most cases, they are going to be buttons or regularly open contacts. Now, how are they connected? Only for our terminal, for its button, which is regularly open. And on the other side of the button, or the terminal, it is going to be connected to our SC terminal. Why? So that it closes out our circuit. And this is only until this is closed that it's going to close out our electric circuit. And that's where it's going to get the drive information. And it's going to run our information. So here, for example, we have our S3, we have our external flaw. And if there is an external flaw, how do we want it to be reestablished? Through a different button. Now, what type? Regularly open. Now, this is configured with our digital input number 4. Now, let's run a drill. We're going to do this together, guys, because you guys, you're actually going to end our complete exercise. Okay, now, what does this consist of? It says page number 54 and 245. Okay, now, what does this consist of? Okay, so we're going to enter our parameters here for our digital input. And we're going to follow H101, which means that this is going to be our digital input. Okay? And so this is going to be number 40 by default, as we can see here. But I want that you please help me out, okay, by assigning these inputs their functions according to what we have as an example. For example, page number 54 in your manual. So in this case, it's going to tell me run, forward, or backward. So let's see if this matches. So run, stop, forward. Here we go. It's actually already assigned, which is our parameter number 40 for H101. So I don't need to modify a thing here. So I'm going to go to my digital input number 2, and it's telling me that it's set as reverse command. So this is for number 41. So let's see if this is true. So here for number 54, it's already assigned by default. However, it's telling me here for my diagram that my digital input number 3 is configured as an external flaw, which is 24. Now let's see what it has here. That's 245. So it's telling me that it has 24. So external flaw. Okay? Now it's saying that it's this. NO, or normally open, it's always going to detect it. And as soon as it detects something, it is going to stop, but with inertia. So in the future, I'm going to explain to you how this works. So then this is already assigned, and this is set by default with 54. So we're going to go with our multi-layer speed. And what do I want it to do now? So whatever it has here for our S7, add it and then configure this to our S1. What we have for our multi-step, which is S6, add it for S2. And S5 changes to S3. And S4, all that I want you guys to do is to change not for parameter number 24. Change it, yes, but please make it a different parameter, whatever it is that you guys wish, okay? Which in this case is going to be within all of these, okay? And also, I'd like you guys to practice by entering these parameters so that you guys can notice how you guys are able to modify these functions for your digital inputs. All good so far? Okay, so this is going to be your exercise. Do it and modify it with your Yaskawa drive. And then I'd like you guys to review your Danfoss manual and try to do the same thing. Okay, but now all I want is that you guys enter your digital inputs and tell me in your comments which inputs and what functions are set by default. So digital input number 1, what does this mean? Digital input number 2, what else does this mean? For example, does it have function or does it have nothing? So with this, we're done with our digital input topic, and now we're going to move on to our digital outputs. Big hug, guys. I'll see you on our next video.